हेलो एवरीवन, वेलकम टू दिस लेक्चर। आज हम लोग करने जा रहे हैं सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री का पार्ट नंबर 3। पिछले लेक्चर में मैंने कहा था कि लॉ ऑफ केमिकल कॉम्बिनेशन क्या है, 5 लॉज दिया था, उसको मैंने पढ़ाया था, समझाया था, तो उम्मीद है कि आपको समझ में आ गया होगा। टुडे वी आर गोइंग टू डू द नेक्स्ट पार्ट। In your book, the next part is Avogadro hypothesis. Avogadro hypothesis you already know, and I have made a separate video on Avogadro hypothesis and mole concept. So that portion I will not teach here in this chapter. Okay, if you want to see, then the video is available on the channel. You can go and watch it. Okay. Today I am not going to teach Avogadro hypothesis. I will be starting from chemical equivalent. The important part is chemical equivalent. So today's first topic is chemical इक्विवेलेंट। दिस टॉपिक माइट बी न्यू टू ऑल, ये नया हो सकता है ये टॉपिक, क्योंकि ये पहले आप लोगों ने पढ़ा नहीं होगा। इक्विवेलेंस, ठीक है। अब समझिए, केमिकल इक्विवेलेंट, किसी भी चीज अगर इक्विवेलेंट हो तो हम कैसे बोलते हैं। सपोज यहाँ पे मैं मैथ्स का एग्जांपल दे रहा हूँ। आपके पास एक ए सेट है जिसमें ए कॉमा बी एक एलिमेंट्स है, और एक एक्स सेट है जिसमें मान लेते पी कॉमा क्यू एक एलिमेंट, ठीक है। इसका कार्डिनल नंबर 2 है, इसका भी कार्डिनल नंबर 2 है। तो अगर कार्डिनल नंबर बराबर हो जाए तो हम इसको बोल देते इक्विवेलेंट सेट। एलिमेंट बराबर नहीं है पर इनका कार्डिनल नंबर बराबर हो गया तो इसको हम लोग इक्विवेलेंट सेट बोलते हैं। तो इक्विवेलेंट सेट क्यों बोल रहे हैं? क्योंकि ये दोनों इसके बराबर है, मतलब हम इससे इसको रिलेट कर रहे हैं। आर वी रिलेटिंग दैट विद दैट, राइट? We are relating this set with this set. We are relating this set with this set. We are relating the cardinal numbers. We are relating the set. So we are saying equivalent set. Equivalent with respect to someone, right? So here in chemistry, chemical equivalent is again with respect to something. What is that with respect? In the definition of equivalent with, you will get 3 things. I am not writing the exact definition. I am just saying you what are the things you need to remember. Number 1, combine slash displace. Of course it can combine और displace, combine भी कर सकता है, displace भी कर सकता है, ठीक है। अब ये combination या displacement directly भी हो सकता है, indirectly भी हो सकता है, ठीक है। combine भी कर सकते हैं, displace भी कर सकते हैं। फर्स्ट 8 हाइड्रोजन, सेकेंड combine कर सकता है, displace कर सकता है, किसको करेगा? ऑक्सीजन। थर्ड किसको करेगा? क्लोरीन। थर्ड करेगा क्लोरीन को। ये 3 चीजों, ये डेफिनेशन में है, इक्विवेलेंट वेट के डेफिनेशन में ही ये 3 है। अच्छा, हाइड्रोजन 1.008, तो हम हाइड्रोजन का मास है वो, ठीक है। ऑक्सीजन का 8 होता है और क्लोरीन का 35.5 होता है, ठीक है। तो डेफिनेशन कहता है कि इक्विवेलेंट वेट वो वेट होता है, वो वेट होता है, मतलब वो मास बाई पार्ट होता है एक एलिमेंट का, जो मास बाई पार्ट वो रिमूव कर सकता है इतना मास बाई पार्ट, या फिर इतना मास बाई पार्ट, या फिर इतना मास बाई पार्ट रिमूव कर सकता है, या फिर इतना मास बाई पार्ट कंबाइन कर सकता है, इतना मास बाई पार्ट कंबाइन कर सकता है, इतना मास बाई पार्ट कंबाइन कर सकता है। तो व्हाट इज एक्चुअली इक्विवेलेंट वेट? It is the mass by part of that substance which can combine with this or displace this. This means what? This means either 1.008 parts by mass of hydrogen, or 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine. Understood? This is chemical equivalent. So you can understand that if there is an element, then we are relating that element's mass by part with this 3, then we are saying it's equivalent weight, right? Because we have the weight of that particular element. If I give you sodium, then sodium has its weight, that is 23, right? That is not equivalent weight, that is weight. But equivalent weight can be equal to its weight, that is a different thing. Molar mass এর সাথে it can be equal, but not necessarily, ঠিক আছে। So what I am meaning is that equivalent weight is that part by mass which can do either of this thing. Either it can combine with this part by mass or displace this part by mass, or combine with this part by mass or displace this part by mass. Simple meaning. ठीक है? Understanding clear है सबको? Okay. Next. So definition should be clear right now. Definition is very simple. Whatever is the part by mass of that element combining with or displacing 8 parts by mass of oxygen, 35 by 5 parts of chlorine, or 1.008 parts by mass of hydrogen. Okay, no doubts. Next. Relating to this chemical equivalent, first coming later on to that. Chemical equivalent weight or simply equivalent weight. What do I mean by that? Definition of equivalent weight is clear. Now we have to determine the equivalent weight of elements. How will you do that? First is equivalent weight. Okay, this is equivalent weight. Okay, I cannot write that every time, so I'm writing equivalent EQW. ठीक है? EQW of what? Of an element. EQW of an element. How will you find out EQW of an element? EQW of element will be equal to that particular element has got some atomic mass. So I will write atomic mass. In case of elements, it's atomic mass divided by the valency of that particular element. Did you understood? कोई भी एलिमेंट का इक्विवेलेंट मास निकालना हो तो हम लोग क्या करेंगे, उस एलिमेंट का एटॉमिक मास जो भी है ऊपर रखो, डिवाइड मारना है किससे? वैलेंसी से. ठीक है. नाउ आप कह सकते हो कि कॉपर 2 प्लस कॉपर 3 प्लस भी होता है, आयरन Fe2 प्लस और Fe3 प्लस होता है, तो उस केस में तो ये डिफरेंट हो जाएगा. यस, व्हाट इज द प्रॉब्लम? लेट इट बी डिफरेंट. So this will be varying with the compound. Whatever is the valency exhibited, it will be different. Okay. Who has told that equivalent weight has to be same for everything? No, can vary. Okay. Okay. So did you understand this? Equivalent weight equals to atomic mass by valency. Let me take one example. Quick example. Sodium. Atomic mass is 23. Valency is 1, so equivalent weight is 23. Unit is there? Not there. Unit is not there. ठीक है जी? Okay. Number 2. Equivalent weight we will calculate now for salts. ठीक है जी? Equivalent we will calculate for salts. What we will do for salts? How will you calculate for salts? How will you calculate for salts? Now, first salt I am taking is for a normal salt. You understand what is normal salt? We have done in class 10. Normal salt का मतलब होता है वो salt जिसमें कोई हाइड्रोजन आयन नहीं है एसिड का, या बेस का कोई OH भी नहीं है. ठीक है. So in that case, whatever will be the formula mass, okay? Formula mass, that is actually the molecular mass only, that will be different in case of ionic, nothing else. So formula mass divided by total charge on cationic part. What did I write? Formula mass by total charge on cationic part. ठीक है. Formula mass by total charge on cationic part. Okay, let's take an example that you might understand it better. NaCl. So how will you calculate the equivalent weight of NaCl? NaCl, if you can calculate 23 plus 35.5, right? Divided by total charge on cationic part is +1. No doubt with that. So +1. So whatever is this sum, that is your answer. What is the sum? Around 58.5, I think, not wrong. Right? Very bad at maths. So if I am doing bad calculations, kindly forgive me. Okay. So this is actually equivalent weight equals to normal salt. equals to formula mass by total charge on cationic part. Okay, I think in your book normal salt is only mentioned. Just let me check it. Normal salt is mentioned. Okay, fine. Next, number 3, equivalent weight of salts acid. Okay, I will go by your syllabus only. Okay, okay. How will you calculate the equivalent weight of an acid salt? Similar thing, that is formula mass. Formula mass of what? Formula mass of that particular formula, right? Formula mass of whatever is the substance present. In that case, that is a formula mass. How do you calculate atomic mass? By writing the values. So individual atomic masses have molecular mass. That is in this case formula mass. It is different only in case of ionic compounds. Otherwise, its formula mass is same as molecular mass. You can consider molecular. Okay, ठीक है? Okay. Divided by previously it was total charge of cationic part. This time it will be acid salt means what? H plus ions present. H plus ions present. Number of replaceable hydrogen atoms. Number of replaceable hydrogen plus ions. Okay. Here there is one word that needs to be focused on. This word. What is the word? Replaceable. The hydrogen must be of replaceable, right? It should be replaceable. If it is not a replaceable hydrogen ion, then it cannot be considered as a acid salt. Okay, it must be a replaceable hydrogen ion. Understand it. It has to be a replaceable hydrogen ion. Okay. Next, let us take an example. NaHSO4. You already know what is this, right? So if you want to calculate the equivalent weight of this, you will be adding 23 with 1 with 32 with 64. You will be dividing by how many? Replaceable hydrogen ions. How will you know which one is replaceable hydrogen? That is a very good question. So here you will see this hydrogen. Okay. By seeing the anion, you can understand which acid it is. Which acid it is? It is sulfuric acid. Sulfuric acid. Up, we know that sulfuric acid is a dibasic acid. Sulfuric acid is a dibasic acid. मतलब दो replaceable ions तो होंगे ही होंगे. तो one is present here means what? That is a replaceable hydrogen ion. Okay, so this is a replaceable hydrogen. So we'll divide by 1. So whatever is the answer will be the answer. Okay. Acha. Acha. If I write NaHPO3, okay, Na2. If I write Na2HPO3, can you tell me what will be the equivalent weight of this? I am writing what everyone will write. See, they will write twice into 23. Very good. Hydrogen 1, phosphorus is 31, oxygen is 48, divided by 1. This is the problem that everyone will create. I am saying this is the problem that everyone will create. Na2HPO3, this is wrong. Na2HPO3, this hydrogen is non-replaceable hydrogen. This hydrogen is non-replaceable hydrogen. Why? This hydrogen is non-replaceable hydrogen. How? How it is non-replaceable hydrogen? Can you guess the acid? Acid is H3PO3. So if H3PO3 is the acid, it is a dibasic acid. H3PO3 is a dibasic acid. So if it is a dibasic acid, does that have 3 hydrogen plus ions replaceable? No, it has only 2. And those 2 have been substituted by 2 sodium out over here. So this hydrogen is not H plus of acid. So if you write this, gone. Understood? Clear? Then instead what will you write? You will say, should I write here below 0? Then the entire thing is 0. Then what is the use of writing this? No, you will not write 0. Why you will not write 0? You will write 2. Why will you write 2? You will have to write 2. Let's make this 1 only, otherwise we will get confused. What is the correct equivalent weight? The correct equivalent weight is 2 into 23 plus 1 plus 31 plus 48 divided by 2. Now, where did the 2 come from? This is a normal salt. This is not an acidic salt. This is a normal salt because I have told you the reason that the hydrogen is not a replaceable hydrogen. It does not come from the acid. It is present there only. It is H3PO3 acid. H3PO3 has two replaceable hydrogen atoms which has got replaced by 2 sodium out there. So the third hydrogen is a non-replaceable hydrogen which will not get replaced. So this is actually a normal salt. So normal salt means total charge on cationic part that I have written out here. Understood? From where and what is coming from where? Okay. So whatever you will get after calculation, that is going to be the answer of this. Okay. So this is an exception, you can see, not an exception rather, but just a basic application I will say. But deviation from normal methods, right? Everyone, basic thing is you will think that H2PO3 is relevant. All hydrogen present in the acids are replaceable. No, everything is not replaceable. You have to be alert. Okay. Acha. Which one we have done? Acidic salt we have done. Next comes number 4, that is equivalent weight of acids. Okay. This I will not take much time because you can understand it very easily. Okay. If I talk about the equivalent weight of acids, then I will get the formula mass of that acid. Okay. I will get the formula mass of that acid and I will divide the acid by its basicity. Hopefully I do not have to define now what's basicity. You should know by now what's basicity. Basicity क्या होता है? होता है कि aqueous solution में per molecule कितना हाइड्रोजन आयंस निकलता है, वही basicity है. Okay, what is basicity? Per molecule how many hydrogen ions released? Per molecule how many hydrogen ions released? How many hydrogen plus ions released? ठीक है? Hopefully you know this. I am not defining it much. ठीक है? This is the basic formula. Formula mass by basicity. Always example, otherwise you will not understand. Okay, let us take a basic one, H2SO4. So equivalent weight of H2SO4 is how much? Formula mass is 98. I memorized it. Okay. Basicity of this is 2. Acha. Always do not judge by seeing this only. Okay. Here you can judge it, but it's not actually the way to judge by seeing this. No, definitely not. Okay. Because you know the reason. Acetic acid also, if you see the number of hydrogen and write the number of basicity, gone. Okay. So this is actually 2. That is 49. Done. Okay. Understood. Next, coming to number 5. Since we have come with acid, definitely the base bhaiya will also come. So this is a base. So how will you calculate the equivalent weight of a base? Base can be calculated by writing formula mass and dividing that by the acidity of that base. Now what is acidity of the base? Acidity of the base is per molecule ionization, per molecule how many OH minus. Acha, one more thing, this happens only in aqueous solution. Okay, that also you already know. Okay, only in aqueous solution, only in aqueous solution. Done. Okay, so this is acidity, this is you already know. So if you divide that, your answer will come as the base. Next, let us check out one example. Sodium hydroxide. Okay, equivalent weight of sodium hydroxide is 23 plus 16 plus 1 by, what is the basicity of this? 1. Sorry, basicity bolchi, acidity 1, right? So this is how much? 17, 50 I think. 23, no, not 50, 40. 23 plus 16 is 39, 39%. Okay, 40. Done. This is 5. Next, number 6. Number 6 is, acha, equivalent weight of oxidant slash reductant. This concept actually you can learn in more details when you have read the chapter redox reactions. Okay, in details you will get it in redox reaction, but not equivalent weight, balancing and all in redox reaction. But you should have an idea of redox reaction in this case because you need that. Okay, the basic formula to find the equivalent weight is the formula mass of whatever substance you have to find out divided by total number of electrons. Understand, total number of electrons gained, that is oxidation or lost, sorry, reduction, what am I saying today, reduction and oxidation, right? So either how many electrons will be lost, not one, total, and how many electrons will be gained, total. So okay, gain is reduction, loss is oxidation, that much you all know already. So formula must be total number of electrons gained or lost. Now what type of questions will come? No one will usually ask you in a separate way to find out the equivalent weight of a compound, but they will give you in a reaction. Let me pick up a question directly from the exercise. I'll pick up one question, then we can understand it. Example I'll pick up, not example, sorry, exercise I'll pick up one question. See here, it's given question, sodium thiosulfite, I'm writing the question, okay, sodium thiosulfite, that is given formula Na2S2O3.5H2O. Okay, this substance reacts with iodine as follows. Reaction given is 2H2O3 2 minus plus I2 forms S4O6 2 minus plus 2I minus. Done. Now it is asking for calculate the equivalent mass of Na2S2O3. Okay. So how will you solve this question, or what approach will you take for this question? Solving is coming later. First you have to see the approach to the question. Asking us is the equivalent weight of this thing, right? So to calculate the equivalent weight, we need the molecular mass, which is 248. Okay, which is 248. Divided by we need the total change in electron, which we do not know yet. So I am leaving it empty. Okay, we will write that later on. Now how to get what is the total change in electron? Understand, in sodium thiosulfite, do we have iodine? So do I need iodine's electron change? No. I need the electron change of this particular thing. I need the electronic change of this thing to this thing. Now how will you know the electronic change? Actually, if you have a concept of redox reaction, then you can already figure out what is the change. Okay, see here. This side, the total negative charge is -4. This 2 into 2 minus -4. Total negative charge on the negative left side is -4. This side it is -2. I am not considering this. No. I am considering only this 2. Here total charge is -2. Here total charge is -4. How much deficient is that side? 2 negative charge. How can I increase negative charge? By adding electron. So where will I add electron? Okay. Okay, don't add in the main reaction, by the way. You will write a separate half reaction like S2O3 2 minus 2. Formation is S4O6 2 minus. Deficient in electron is this side. So 2 electron. So to convert from this to this, I am having a change of how many electron? 2 electrons. Understand now thing. Wait. Understand the thing. To convert from this thing to this thing, I am needing 2 electrons. Right or wrong? I am needing 2 electrons. For how many sulfur I am needing 2 electrons? Here. 2. 2 sulfur is needing 2 electrons. 1 sulfur will leave 1 electron. So molecular mass will be, okay. This might be confusing, but you have to read the reaction chapter. The moment you read the redox reaction chapter, it will be more clear to you. Did you understand? It will be more clear to you. If you read redox reaction, it will be more clear to you. As of now, just understand, here 1 sulfur will release 1 electron only. Or if I am taking in more details, then 1 molecule of this will release 1 electron. 2 molecule is releasing 2 electron, so 1 molecule will release 1 electron. Simple unitary method. 1 molecule will release 1 electron. 2 molecules releasing 2 electrons. Clear? No doubt with this. I think it's clear. Okay. So the total change electron is 1. So divided by 1, that is 248. Clear? So किया क्या आपने? किया कि formula mass में total number of electrons gained or lost. So we have to find how many electrons are gained or lost. Here we wrote this half reaction over here. This half reaction. This was the main reaction given in the question, where we have seen this portion is not needed because this portion does not consist in our question. It is a part, but it will not be required in the question because Na2H2O3.5 is nothing to do with iodine. So we will not consider this part. We are considering half reaction, this part. So from here to here, the change is of 2 electron change. This can lose 2 electron to form this. Okay. So one will lose 1 electron to form this. These 2 molecules are losing this to form this by 2 electrons. So one will lose 1 electron to form this, right? So I have divided it by 1 because I have to write for 1. Am I writing for 2? I am not writing for 2. I am writing for 1. So why should I divide it by 2? I should divide it by 1 only. Okay. So we are divided by 1. Done. Over with this. Understood? This is all about, we need to read from equivalent weight. Next, you see in your book, it is given directly. This entire thing is a mole concept, which I am not going to talk about. You already know what's a mole, and all those I have already given in the other video. You can just go and check it. Next, determination of relative molecular mass is not there in the syllabus. It is out of syllabus. We'll check. You can read it for your choice. Of course, you can read it. It's interesting. Next, we will come on to the final topic, that is volumetric calculation. Volumetric calculation. Now, if I talk about volumetric calculation, we will mainly deal about titration. Okay, titration. New term for you all. New term. Volumetric calculation. Titration. Okay. What is titration? Basic thing about titration is, you have one unknown substance. We do not know what is the unknown substance. First, let us take like that. We do not know what is the unknown substance. How will you know the unknown substance? By performing some chemical test. Okay. Suppose you have in your hand sodium hydroxide, but you do not know it's sodium hydroxide. What can you do possibly? To react with something to check what it can possibly be. Okay. In titration, you have a solution. You know the solution, but you do not know the strength. Okay, and you may not know, that is a different thing. Usually it's known, maybe it is unknown. So let us take unknown only. You do not know a solution and you want to know its strength. In that case, knowing the strength of that unknown solution, with the help of a known solution, you strength also you know. By using that, if you are finding out the unknown solution strength, then that is called titration. Okay. So what is titration? Knowing strength of unknown solution by using a solution of known strength. Clear? So if we are using a solution whose strength we do not know, that will calculate. For that, if we are running another solution whose strength we know, then that is called type. This process is called titration. Okay. Now in your book you will find this is titration definition is given over here. Unknown solution is given by the term you can understand. Acha. Known solution which you already know given standard. Primary standard, secondary standard. Just few definitions are there. You can just go through it. Okay. I'm not discussing about that because it's generally not asked. Okay. Next, coming to the composition of the volumetric analysis. Now this is the very important portion. To express the concentration of a solution, students, to express the concentration of a solution, we can use variety of terms. Variety. Okay. First one you have is mass percentage. What is that? By the name all you can understand that mass divided by mass into 100. This mass of solute by mass of solution into 100%. Acha. Let me just check if you have got mass percentage, volume, gram per liter, molarity, molar. Okay, so what I was telling, mass percentage. Mass percentage is actually mass of the solute divided by the mass of the solution into 100%. As simple as that. You need to remember this thing because you will be applying this thing only. Clear? So mass of solute by mass of solution into 100 gives you the mass percentage. Always remember, when you are representing the concentration of a solution, that means we are trying to represent the concentration of the solute in the solution. Clear? So above one has to be solute. Okay? Even if you forget anything, कुछ भी भूल जाओ, पर ऊपर वाला solute ही होगा, क्योंकि हम लोग जो concentration का definition है उसमें ही तो बोल रहे कि it is the concentration of the solute, it is the mass of solute per solvent, per unit solvent. Okay? So mass percentage is clear, not at all difficult. Right. Next, volume percentage. What is that? That is volume of solute. Again solute. Okay, please note it down. Volume of solute by volume of solution. If I multiply that by 100%, then I will get the volume percentage. Clear? Not difficult. These formulas are the thing you need to remember. Mass means mass of solute by mass of solution. Volume means volume of solute by volume of solution. Done. Clear? Next. And the next one is mass volume actually. Okay. We say it as grams per liter. It is actually mass volume. That is what? Mass of solute. You can understand the unit only. Mass of solution gram divided by volume of solution in liter. I wrote one wrong thing. This mass volume of solution I wrote. Mass of solute by volume of solution. If it is the thing, then it is said to be gram per liter. So you can understand from the unit only that mass of solute is in gram. So gram per liter. Understood? So these are the basic ones, not difficult ones at all. The next thing that will be coming up will be a new term for you all and will be one of the most important term. Molarity. You will be getting confused by the three members of the family. There is a family. Okay. There is a family. I'm just giving you a short hint. Family, one member of the family is molarity. Another member is molality. Another member is normality. Another member is formality. So this is one family. The family has 4 members: molarity, molarity, normality, formality. And these 4 members will be confusing your brain, okay, because they are very close but they are different. Okay, coming to the first member of the family, that is molarity. Please remember, in the name only, if you properly see the name, then you will be getting this part. What is it? Mole. Mole, can you see in the name? Mole. So this means M, okay, denoted by M. M equals to number of moles of the solute divided by the volume of the solution. Clear? Mole, written number of moles, divide by volume of the solution in liters. In liters there is some relation as well, in liters. Clear? So mole, written mole divided by volume always. So this particular relation gives us the equation for molarity. But straightforward questions we will not get directly, or very rarely will get the straightforward questions. Right? Then what to do? Nothing. You will understand. You can understand everything. Okay. N is number of moles. How do you calculate number of moles? कैसे calculate कैसे करते हैं number of moles को? एक given weight रहता है. Let us take that given weight is W. This is small w, okay, my small w, big W looks same. This is W divided by, if I am using the term symbol, M. Molecular mass of that substance, and numerator is the given weight of that substance. Okay, that is the molecular mass. That is the number of moles. Suppose you have 23 gram of sodium. The number of mole is 1. How did you calculate that? 23 by 26. So you did. That is what I have written. Okay. Suppose you did not have 23. You had 46. Then you would have been dividing 23 by 46. No, it was 46 by 23. Right? That is what we have done. Clear? Okay. This volume, I am converting it into centimeter cube. Okay? This is in centimeter cube. Clear? This is in centimeter cube. Any doubt? No doubt. This is in centimeter cube. Liter to centimeter cube is 1 by 1000. 1 liter is 0.3 by minus 3 centimeter cube. So now putting this in this equation, M equals to N at jayega W upon capital M. Now you see capital M will become similar. So I will use a term dash. Okay, dash. Okay, W by dash divided by V by 1000. So can I write M equals to W into 1000 divided by M dash into V. This V is small v, okay. So when I have to calculate this weight, then weight will be equal to what? M molarity multiplied by this divided by 1000. So this is one required equation. This is one of the required equation which you will be using. Did you understand? Where did the required equation come from? Simply we have taken the number of moles as W by M that you know, and V equals to V by 1000. Right? So this is giving us the answer in centimeter cube. This is a weight, particular weight which we have taken, and the relation is in centimeter cube grams. Clear? Understood? These are the two important equations. One equation is over here and the second equation is over here. These two equations are very important and you have to know it. Okay? This equation is not to be memorized. You can just derive it like this. If you can memorize, of course you will. But if you cannot, then you can just derive it. Okay? There is no problem in regarding derivations. Clear? Okay. Molarity done. Next, the second member of the family. Who is the second member of the family? Molality. Acha. Before moving on to molarity, let me just tell you a few terms. Molarity depends on volume, so it will change with temperature. Okay. Molarity depends on volume, so it will change with temperature. Then next. Acha. Many places you will find M solution, it is written. M solution. What does that mean? 1 molar solution. Okay, please know these terms. M by 2 you will find many where it is written. M by 2. That means so you can understand only half molar solution. Okay, this is also called molar solution. Okay, this is called semi-molar solution. Okay, semi-molar. Semi means half. Next you will find 2m solution somewhere written. This is binormal or 2 molar solution. Okay, that is bimolar solution. Okay, so like this you will get many. Like you will another you have, that is m by 10 solution. M by 10 means what? 1 by 10 molar solution. 1 by 10 means what? Centimolar solution. Like this you will get many. Right, centimolar. That decimolar solution. Like this you will get many. Decimolar. Then 1 by 100 you will do m by 100. Then you will get centimolar solution. Clear? Like this, you just need to know few notations because it can be asked randomly, it can be given. Okay, either of these symbols can be used in the paper. You need to know that what does the symbol stand for. You should know the symbol. Okay, anything else is mentioned in your book? Let me just check it out. See here it is written in table 1.5, m, m by 10, m by 100, m by 2 and 2m. Done. Next we have seen here it is written clearly, it is written in bold letters that molarity of the solution will change with temperature. Okay, I am also writing over here. Molarity will change with temperature, as I said already. Molarity changes with temperature. Okay, molarity changes with temperature. Why? Because volume is dependent on temperature. Volume is dependent, so volume is dependent on temperature. Since volume is dependent on temperature, molarity will also be dependent on temperature. Simple logic is there. Done? Okay. Next member of the family is formality. Next member of the family is formality. Now do not think that formality, being formal, no, that's English formality, not chemistry formality. Okay. Formality is denoted by F. And this formality is equal to, understand, number of gram formula mass. Wait, something not a big, very big term. Number of gram formula mass. Okay, I am not writing whose, you know already whose, solutes, right? Divided by the volume. Liter. Okay, please do not write the volume of solute, it's volume of solution. Writing on that, otherwise you will get confused. Volume of solute. ठीक है? So this is number of gram formula mass of solute divided by the volume of that solution in liters. If it is not in liters, then you have another equation. Okay. Acha. If I am denoting this number of gram formula mass by x, x equal to number of gram formula mass. See now, you will get similar relation. Number of gram formula mass of solute. Okay. Okay. Then what will be x equal to? If you use your common sense, even you can understand. The gram for given weight, let's say W, divided by the gram formula mass. Right or wrong? Whatever is the given weight divided by the gram formula mass, because formula mass, gram formula mass means how many gram formula mass are there, right? So this is one equation. Another equation, you already know what is the equation, V by 1000, that is in centimeter cube. Putting this in main equation, so you will get F equals to W by M dash divided by V by 1000, that is equal to F equals to W into 1000 divided by M dash into V. So I need to get the hold of this W. So W will be equal to what? F into M dash into V divided by 1000. So you find out that there is not much difference in the molarity equation and this equation. See, more or less it is same. Just instead of this M, the F has come. Because things are same, why will the thing change? Understood? Okay, now you will tell me, does this function change with temperature? Of course, depending on volume. So even this changes with temperature. changes with temp. Okay, temp is temperature. ठीक है. So we have discussed formality. Who is the next member in list? Molarity. Small m. Okay. Till now we have discussed about molarity. Molarity means mole by volume. Formality means gram formula mass number divided by volume. Okay. Acha. This cases m by 2, 2m, m by 10, m by 100. This can be possible for this also. I am not writing that because you can understand automatically. Okay. So should I write that? Then I am writing the list only. I am not writing the names because names will be same as that. Okay. So you have f. You have f by 2. You have f by 100. You have f by 1000. 10. Sorry. And 2f. If these are given in the question, then you will get the same names as given above. Acha. Same name does not mean that the ditto copy of that. Okay, please. If you end up writing semimolar solution for 2f, then I have got nothing to say. Okay, so these are all the same names with formal substitution. Okay, next comes molality. Now, who is this molality? The third member of the family is molality. Molarity is R over here. This is molality. Molality. Okay. Okay. Small m is actually written as n n number of moles of the solute divided by mass of the solution, that will be in kg. Now tell me, in case of molarity, we have seen number of moles of solute, very good, but divided by volume. But this is also number of moles, but divided by mass. You can see here also the term mole is there, here also the term mole is there, here also the term mole was there. So both the cases mole, but division by mass in this case. Do you understand it? So similar type of substitution I will do. N equals to W by M dash and V equal to V by 1000. Will it be very useful to write V equal to V by 1000? Will it be very useful to write V equal to V by 1000? No. Why? Because V is not required. Okay? So what we will write? Instead of V, I will write M. Because I need M. So I will write M. Let's make it this capital M. The capital M will have a Oof. Let us make this capital M. Pen I am using randomly. Just a minute. We make this capital M equal to small. Okay. Putting this in this equation, I get small m equal to W by M dash divided by M dash by 1000. Okay. So I am getting M equals to W into 1000 divided by M dash into M dash. So when I am writing the weight calculation, then that becomes molarity into this by 1000. Okay. So this is the equation which you will use according to the need of the question. Clear? So molarity is actually what? Number of moles by volume, while molality is also number of moles but divided by the mass of the solution in kilograms. Okay. If it is in gram, then use this equation. Clear? Next member of this family is Mr. Normality. Number 7. Normality. Normality is denoted by N, and this personality is different from others. Wow. This means number of chemical equivalent. This means number of chemical equivalent, or you can say gram equivalents, okay, divided by volume. Okay. Number of chemical equivalent, or you say gram equivalent, okay, similar thing, divided by volume of solution. This is normality, different personality. Okay, so number of chemical equivalent divided by volume of solution gives you normality. Okay, this thing, if I am denoting this thing by x, so this thing will be what? Weight divided by the equivalent weight. Right or wrong? If I have to find out the gram equivalent weight, then I should divide that by equivalent weight. So this will be W by EQ. And if I have to find out, this should be V by 1000. This is centimeter cube. So combining these two equations, I have normality equation equal to number of chemical equivalent, that is W by EQ divided by V by 1000 is equal to normality equation equal to W into 1000 divided by EQ into V, that is equal to W equal to normality into EQ into V in divided by 1000. Clear or not clear? So see, in case of all the things, we are doing similar type of substitution. Aren't we? Similar type of substitution we are doing. Same substitution. You can see this we are calculating, we are putting the value, we are writing this. Not different. Same thing. Directly we use that equation. ठीक है? Okay. Who is the next member of our family? This is all it's given in your book. It is given as this value done. Okay. So we have done normality. Done. Done. Normality done. Done. Okay. N by 10, N by 10 I'm not discussing. I think you already know that. Okay, another thing I forgot to say last time. Molarity I have not mentioned that. But you will write this. Very important one. Does not change with temperature. Okay. Does not change with temperature. Why it will not change with temperature? Because it is not a function of volume. Volume is a function of temperature, but its mass is not a function of temperature. Why will it change? Okay, so similar cases are happening in molarity also. Molality also, so we'll use the n by 10 and all that. ठीक है? This one also we are having n by 10, n by 2, all that. So you already know what is it. ठीक है? So you are having n by 2, n by 4, and sorry, n by 4 बोलছি. N by 10, n by 100, n and 2n. Then you will be writing same term. ठीक है? Next is changes with temperature. Why? Because it is dependent on volume. Changes with temperature. Changes with. No doubt with that. Last member of our family and last topic of today's video as well is molarity. No, mole fraction. Mole fraction. Now, as from the name itself, you can understand fraction. Fraction. So mole fraction is denoted by chi. Okay, chi. Chi actually like this. Okay. This mole fraction can be of two components. Let us take that there is A and B in a solution. A and B in a solution. Okay. So mole fraction of A I will write as number of moles of A by total number of moles where in this particular solution. Okay, total number of moles. Similarly, if I have to find out this, then I will be writing number of moles of B by total moles. Okay, in this. So whosoever mole fraction I have to find out now, I will be using that number of moles of that substance divided by the total number of moles within the solution. Now since this you can understand also that since this is a fraction, then definitely this value plus this value should be equal to 1. Has to be equal to 1. Always has to be. Has to be or not has to be? Because this and this will again add up to this. This will divide by this is 1. So this thing should be always 2. If somehow by some chance this is not coming to, means you are something error is there. There is no exception to this not coming to. Clear? Any doubt with this? No. So this is mole fraction you have to do. Okay? Mole fraction depends on temperature. So it is no way going to change with the temperature. Okay? It is no way going to change with temperature. Does not change with temperature. Because it is not a function of volume. Clear or not clear? Any doubt with this? Hopefully not. So see, we have completed the topic of this portion: volumetric calculation, mass percentage, volume percentage, gram per liter, molarity, formality, molality, normality, mole fraction. Okay, we have completed this. Next comes some numericals are there and numerical related topics are there. In the next video, I will be discussing a little bit about empirical formula. You already know maximum empirical formula, and I will be discussing about stoichiometry of reactions in the next videos. Okay, so that's all from my side in this video. Hopefully you have understood the topic. So let's just quickly just recap what we have done today. We have discussed chemical equivalence. Definition of the chemical equivalent is, we have discussed that. Then we have seen what is chemical equivalent weight of an element: salt, normal salt, acid salt, right? Acid salt, acid, base, oxidant, reductant. We have seen a question: volumetric calculation, mass percentage, volume percentage, grams per liter, molarity, molality, formality, molarity is here, normality, and mole fraction. Clear? So this is constituting a heavy branch of chemistry, and it's important part of chemistry. Molarity, normality, because it will be used in lot of places. Okay, so hopefully you have understood these topics. Please do revise and read, otherwise you'll keep forgetting. Even I keep forgetting sometimes. I also need to recollect. Okay, so let's meet in the next video. Stay safe.